Greetings of the day, dear students. In this video, we are going to discuss about the calculation of energy consumption, how we are going to calculate the amount of energy consumed by a particular equipment, electrical equipment, right? And what will be the units for power and what are the units for energy, how the power is different from energy, right? How the power is different from energy, and slowly we will discuss for a given electrical load, if it is operated for some period of time, how much will be the electricity bill or how much will be the amount to be paid for the energy consumed. All those things we are going to discuss in this video, right? Dear students, most of the students will get confused here with respect to the power and energy. With respect to the power and energy, we are already familiar that power equals to work done by time, power equal to work done by time, and the work done we will express it in joules and the time is expressed in second. So joules per second, we are having a unit called watt. So the power is expressed in watt. 1 joule per 1 second is treated as 1 watt, is treated as 1 watt. So the power units are watts and the energy units are joules. The power units are watts and the energy units are joules. Now if this magnitude of power is very high, then instead of expressing it the power in watts, we will use or express it in kilowatts or megawatts and gigawatts, like this. So you are already familiar. Kilo means 10 power 3, right? Mega means 10 power 6 and giga means 10 power 9. For example, somewhere if you come across the word 3 kilowatt, its meaning is 3 into 10 power 3 watts. So it is 3000 watts of power, 3000 watts of power. So like that we have to understand with respect to the power, right? Now the same power, if you are expressing it in terms of voltage and current with respect to the electrical point of view, for example, here you are having a load, dear students. For this load, an electrical load, it can be any electrical load, it can be a fan or bulb or AC or refrigerator, whatever might be the equipment, right? Depending upon its power rating, each equipment will have its own power rating. For example, you might have heard the word like 100 watts bulb, 100 watts bulb, right? And if it is a fan, if it is a fan, it will be some around 75 to 90 watts, 75 watts fan. Or if it is an air conditioner, AC, it will be around some if it is some 1.5 ton AC, some 1500 to 2000 watts. These are all called the power rating of the equipment. That means if you use this bulb or fan or AC, they are going to draw this much amount of power. That is the meaning. If you apply its rated voltage to the equipment, this bulb is going to draw 100 watts if the bulb is made on. Similarly, if the fan is made on, switched on, it is going to draw 75 watts of power. Similarly, this AC. So these are called the power ratings of the equipment. Power rating of the equipment. Now depending upon the power rating, the load will draw some amount of current. The load will draw some amount of current. Now if you multiply the voltage applied to the load and the current drawn by the load, you will get the power consumed by the load. You will get the power consumed by the load. So this product of V and I, V is the voltage applied to the load and I is the current drawn by the load. So if you multiply these two, you will get the power drawn by the load. Power drawn by the load, which is expressed in watts or kilowatts or megawatts, if depending upon the magnitude of the power, depending upon the magnitude of power. Now if you want to express, the energy, how we can write it? Our primary focus is on energy. But once if you are clear with power, then we can go into the energy concept. Now this work done or energy is given by power into time. Work done or energy is given by power into time. Energy equal to the power drawn by the load into time. For how much time period it is drawing the power, for how much time period. For example, you switched on the fan, the fan is drawing 100 watts of power, but the fan is continuously kept in on position for 10 hours. Then the energy consumed by the fan is equal to 100 into 10. It will be 1000. What are the units? Watt hour, WH. Very, very important, dear students. So I repeat again. So here you are taking a fan. The fan is drawing 100 watts of power, but the fan is in on state. It is continuously in on state for 10 hours. Then during this 10 hours period of time, it will consume energy of 1000 watt hours. This is very, very important. Now if the power is drawn is only just 1 watt and the time is for 1 hour, then it will be equals to 1 watt hour. Right? Similarly, just like we have expressed the watts in kilowatts or some megawatts or some gigawatts. This is the power, right? Similarly, the energy which we have expressed it in watt hour, you can express, if the magnitude of energy is more, we will express it in kilowatt hour, kWh. K for kilowatt hour, kWh. K for kilo, W for watt and H for hour. Now the electricity bill we will pay is for 1 kilowatt hour is called 1 unit of electrical energy. 1 unit of electrical energy. This is very, very important, dear students. Electrical energy. 1 kilowatt hour. So how do you understand that? For example, dear students, you are having a source and now you are having a AC, air conditioner. Its power rating is 2000 watts. Now AC power rating is how much? 2000 watts. Its meaning is once you switch on the AC, it will draw 2000 watts. Now the time period, daily you are making it on for 5 hours. So in a day, in one day, monthly bill how much you can get? Monthly bill, how much energy it consumes. For example, monthly bill can be how much? For that sake, if you know how many units it is consuming in a total month, then you can tell the total cost of the bill. If 1 unit of electricity is equals to the 5 rupees, 1 unit equal to the 5 rupees, then how much you can get the bill depends upon the energy consumed by the AC, right? Now what will be the energy consumed? Energy per day consumed in a day will be power rating, power into time. So here what is the power? 2000 watts into what is the time? Every day it is getting operated for 5 hours. So this is around 10,000 watt hours, but express it in kilowatt hours. So it is around 10 kilowatt hours, but 1 kilowatt hour equal to 1 unit. Therefore 10 kilowatt hours means it is equal to 10 units of electricity. 10 units of electricity you are consuming every day. 10 units of electricity you are consuming every day. That means for each unit, if the price is 5 rupees, for 10 units cost per day, each day you are consuming 10 units of electrical energy. So cost per day will be 10 units into the price of each unit. I have told you 5 rupees. So 10 into 5, 50 rupees you are only for AC you have to pay daily 50 rupees. Like that you have to understand. Just for AC, air conditioner, which is drawing some 2000 watts or which will draw some 2000 watts of power, this is the power rating. Whether you use it for half an hour or 1 hour or 2 hours, its power rating will be same. The power rating will not change. Once you switch on the AC for 5 minutes also, the power rating will be same. But what will be the different? Energy will be different. If the same AC, if you are making it on for 5 hours, if you are using it for 5 hours, right, the energy will be power into time. The power rating is 2000 into time is 5 hours. So we will get 10,000 watt hours, but the amount we pay is for 1 unit. 1 unit means 1 kilowatt hour. For that sake, this watt hours we have expressed it in kilowatt hours. It is around 10 kilowatt hours. 1 kilowatt hour means 1 unit. So 10 kilowatt hours means 10 units of electrical energy. If each unit price is 5 rupees, then 10 into 5, 50 rupees we have to pay. 50 rupees per day we have to pay. If the same, if your month is having 30 days, for 30 days daily if you are using the AC, how much you have to pay? 30 into 50 rupees. Daily if you are using AC for 5 hours, 30 into 50 rupees. 3 5s are 1500 rupees only for AC you have to pay. Right? Yeah, like this the energy is to be calculated. Now to make you understand better, in the place of AC, for example, if you are having fan, but the fan rating is 100 watts, daily 10 hours you are using the fan, right? Then energy will be equal to how much? Unit price is same. For example, unit price is same. You are having a fan which is drawing 100 watts of power, but you are making the fan operated daily for 10 hours. Each day you are making the fan in the on state for 10 hours. Then how much could be the energy consumed by the fan? That is energy equal to power into time. You know the power rating of the fan. It is drawing 100 watts. If you are making that fan on for 10 hours, so it is around 1000. The units are watt hours. So 1000 watt hours means nothing but 1 kilowatt hour. But 1 kilowatt hour is nothing but 1 unit. Daily you are consuming 1 unit of electrical energy. So cost per day is 1 unit into the unit price is 5 rupees. So 1 into 5 it is 5 rupees. So cost per month, 30 days if you take 30 days and each day 5 rupees, 30 into 5, 150 rupees only because of one fan. if you are having 3 fans in your house, if you are having 3 fans and each fan is taking if it is taking some 150 rupees, right, and if you are having 3 fans, obviously just for fans purpose you have to pay some 450 rupees. Only because of using these 3 fans you are going to pay an electricity bill of 450 rupees if you are making those fans in on state for 10 hours, right? Like that, depending upon the power rating and number of hours it is in on, you can calculate the energy. Once you if you express it in kilowatt hour and convert it into the units, and if you know the unit price, you multiply that units into price, you will get the total cost. But the basic fundamental is power is work done by time. Work done is expressed in joules, time in seconds, right? 1 joule per 1 second is 1 watt. Now if the magnitude of power is more, you will write it in kilowatts, megawatts and gigawatts. If you are having a load of power rating P, and if it is drawing some current I and the applied voltage is V, then the power drawn will be equals to the power P equals to VI, right? Now the energy is expressed it in kilowatt hour or watt hour, power into time. The power is in 1 joule and time is in 1 second, 1 watt second. That is the basic unit actually, but for measuring the electrical energy you will express that in kilowatt hours. kWh, kilowatt hour, is a bigger unit of electrical energy, right? When larger appliances are drawing the power in kilowatts, that is a bigger unit, right? Like that you have to understand. Like this you have to calculate the bill. Okay, here is one more example. If you are interested, okay students, thank you. Okay, thank you.